All right, here we are for Honors Physics Universal Gravitation Worksheet 3, Problem 3. This one is asking about this concept, about this quote. Supposedly, during the Apollo flight to the moon, a well-known TV newscaster made the following statement: "The Apollo spacecraft is now leaving the gravitational force of the Earth." Explain what's wrong with the statement and what you think the newscaster might have meant to say. So, for starters, just to help us think about this, let's jot down the formula. So you say, hey, Newton's law of universal gravitation, that goes like this. Gravitational force is big G, mass of the first object, mass of the second object, divided by the distance between them squared. And you say, now look, if we have a spacecraft on its way from Earth, heading to the moon, right? Then you say, now look, as it heads out, you say, is it really going to leave the gravitational pull of the Earth? And you say, now wait, according to the equation, how big would that distance have to be for that gravitational force to be zero? And you say, you kidding me? To divide by a number, how big does that have to be for this to be zero? That would have to be infinite, wouldn't it? Okay, it wouldn't reach zero. As you make this distance bigger and bigger, this force gets smaller and smaller, but it never reaches zero until you get to infinity. So what I think the newscaster meant might have been this. And I don't know what point during the travel they said that, but if I had a spacecraft and we're heading from Earth to the moon, let's just say it's there. You say, well, there's going to be two forces acting on it. There's going to be a gravitational force from the Earth, and there's going to be a gravitational force from the moon pulling on it. So force of gravity on the spacecraft by the Earth, force of gravity on the spacecraft by the moon, on by notation, double subscript notation. And so you say, well, are these going to be this? You say, at this point, I'm closer to the Earth, so that R is smaller than I am to the moon. And the mass of the Earth is bigger than the mass of the moon. So the attraction between the spacecraft and the Earth is definitely going to be bigger. So if we were to set something still here and let go, it would fall to the Earth. But if it gets close enough to the moon, then it's going to be the reverse situation, wouldn't it? If it's close enough to the moon, the attraction to the moon will be bigger than the attraction to the Earth, and it would tend to fall to the moon. So perhaps, maybe, it's not that it's leaving the gravitational pull of the Earth, because it can't, right? A, it goes out forever. B, you know what's keeping the moon in orbit? The gravitational field of the Earth, right? You're not going to leave the Earth's gravitational field here. That's what's so on the way to the moon, because it's got to be there. It's big enough to hold the moon in place. But I think you're at the point where maybe what he's saying is, now maybe we've gotten to the point where we're going to tend to fall to the moon rather than fall to the Earth. That we're now that gravitational force of the moon is more important, it's larger at this point. Maybe that's what he meant. It's a not too long calculation to do that, to find the position between these two where those forces would balance. And you say, well, obviously, it's not going to be right in the middle, because the Earth is more massive than the moon. It's going to have to be a closer distance, so the force gets bigger, to the smaller mass, right, to make those two balance out. It's not that bad of a calculation to do it. You end up having to solve a quadratic, but it's no big deal. Okay, just going to leave it at that. That's problem 3.